All right, let's talk about something every Swift developer has to deal with, JSON. But, we're not going to do it the old school, painful way. Today, we're diving into how modern Swift has totally revolutionized this whole process, making it cleaner, way safer, and honestly, a lot more fun.
So, let's start with a quick, honest-to-goodness question. Are you still wrestling with JSON by hand? You know the drill. Digging through dictionaries with string keys, chaining a bunch of iflets and guardlets together, just hoping you didn't make a typo somewhere? Yeah, we've all been there. It's not great.
Well, if that last slide felt a little too real, I've got some fantastic news for you. Those days of manual, error-prone dictionary diving are over. There is a much, much better way to do this. A way that feels truly Swifty. And the hero of this story? It's a protocol called Codable. Seriously, this isn't just some little helper tool. It's a complete game changer for how we handle data in Swift. It's the modern answer to an old, annoying problem.
So what is this Codable thing really? Well, it's actually a combination of two other protocols, encodable and decodable. When you make your type conform to Codable, you're basically teaching it how to turn itself into JSON and, more importantly for us right now, how to create itself from JSON. It's a two-way street, and the best part is, Swift does almost all the work for you.
And here's where it gets really, really cool. Look how simple this is. You take your normal Swift struct, you add Codable at the end, and that's it. You're done. This quote struct is now a fully capable, network-ready data model. As long as your property names, content, and author match the keys in your JSON, it just works. No extra code needed.
Okay, so how do we actually put this to use? It's basically a three-step dance. First, you get your raw JSON data, probably from an API call using URL session. Second, you create a JSON decoder object. And third, this is the magic line, you just call .decode, tell it what you want to create, in this case a quote, and hand it the data. Swift handles the entire mapping process behind the scenes.
And boom, the result? You get a proper type-safe quote object. You can use dot notation like .content and .author. You get auto-completion from Xcode, and the compiler will yell at you if you make a mistake. You can say goodbye to those frustrating runtime crashes because you mistyped a dictionary key.
So we've got our model, and we can turn JSON into real Swift objects. That's awesome. But now for the next step. How do we actually get this data to show up on the screen in a modern Swift UI app?
This right here is what a network call looks like in modern Swift UI. We wrap our code in a task to run it asynchronously, and then we use this beautiful async await syntax. No more messy completion handlers. We just try await our function that fetches the quote, and if it works, we assign the result directly to our state variable. It reads just like simple top-to-bottom code, but it keeps our app's UI totally responsive.
And showing the data is just as clean. Our quote variable is probably an optional @state variable that starts out as nil. So in our view, we just use a simple if-let to unwrap it. The second our network call finishes and that state variable gets a value, Swift UI sees the change and poof, this part of the view just appears on screen, all by itself.
So let's just quickly break down why this pattern is so powerful. The API call happens in the background, so your app never freezes. The data we get back gets put directly into a state variable that SwiftUI is watching. And as soon as that state changes, the UI automatically redraws itself to reflect the new data. It's a beautiful declarative system.
And I really want to stress this. This isn't just some clever trick. This combination of async await for fetching, Codable for decoding, and @state for driving the UI, this is the standard recommended way to build data-driven apps in modern Swift UI. This is the foundation you want to build on.
Okay. I can hear you thinking, sure, that's great for simple, flat JSON. But what about the real world? What about those APIs that send back complex, nested objects? Can Codable handle that? Oh yeah, it absolutely can. Let's take a look.
So here's a perfect example. Let's say you have a user object, and inside that there's a nested stats object. How do we model that? Well, it's actually super intuitive. We just make two structs, a user struct that has a property of type stats, and then a separate stats struct. And of course, they both conform to Codable. It keeps your code super clean and organized.
And this really gets to the core philosophy of Codable. Your Swift types should just mirror the JSON structure. If the JSON has a nested object, your Swift struct has a property that is another struct. It's that one-to-one mapping that makes it so easy to understand what's going on.
And now for the best part.
After we set up these nested structs, how much more complicated does our decoding code get? You ready for this? It doesn't change at all. It is still the exact same single beautiful line of code. You just tell the decoder you want a user, and it automatically figures out how to decode the nested stats object all by itself. So, the big takeaway here is that your data structure stays perfectly intact all the way from the server to your app. The hierarchy is maintained, everything is type safe, and your code stays incredibly simple to read no matter how complex the JSON gets. No more digging through nested dictionaries ever again.
So after seeing how clean, safe, and powerful Codable and async await are together, doesn't it just make you want to go back and refactor some of your old networking code? I bet the answer is yes. Thanks so much for joining me, and happy coding!